we will graph, that we will solve, that we will apply, analyze, interpret. And we start with the quadratics and then kind of just build on that pattern. So if you open your packet, we're actually starting with section 4.3. The first two sections are graphing, and if I were to write the book, I would have graphing last, because we need to know how to solve so that we can find all the pieces of the graph, and then we're going to apply that to the graph. So we've got to talk about the solving first. So see if you can, the whole first page is like a little warm-up. See if you can remind yourself what FOIL means, and try and FOIL those 6 terms, 6 binomials together. Jack, do you remember what the FOIL acronym represents?
First, outer,
And it's a way to factor, multiply. It's kind of the opposite of factoring. So it's a way to multiply terms together. So he said first, outer, inner, and then last. So it's a way to multiply a binomial times a binomial. 2 things times 2 things. So Dimitri, for number 1, if we multiply our first terms, what do we get?
X squared.
And then the outer terms.
7x and 4x and then 20.
And then 28. Are there any like terms to combine?
7x and 4x, which would be 11.
Right. And then you get 28. So when you're foiling those inner terms, in most cases they're going to be able to combine together. They would be your like terms. So this is what your answer should look like. You're not doing anything else with that answer. We will be doing the opposite today, and we'll be factoring it. So foiling and factoring are opposites of each other, like multiplication and division are opposites of each other. So looking at the second one, x squared minus 2 and x plus 3. Josh, can you give me your solution, x squared minus 2, x plus 3?
X squared plus x minus 6.
Yeah. So x squared plus x minus 6. Again, you're using that foiling. So we have a positive 3 and a negative 2. The third one, it can also be m. It doesn't have to always be an x, and we'll interchange those variables. So Nina, we have m minus 8 and m minus 9.
That'll be m squared minus 9m plus 2 minus 8m. And that would go down to m squared minus 17m plus 72.
Nice job. Just watching those signs. Carrying those signs through the double negative makes that positive 72. JT, how about z plus 20 and z minus 20?
Z squared plus 20z minus 20z.
Yeah, nice. And what happens with those middle terms? They cancel. So these middle terms are opposites of each other. They cancel. That happens because we have opposite signs, but the same terms in the binomial, just with a plus or a minus. So he said z squared minus 400. Number 5 and 6 are written a little different. We have one parenthesis and it's squared. What does that mean if we have one parenthesis squared, Chris?
So like for number 5, that means it's just like 2 plus 9.
Right, it's 2 of that quantity, d plus 9. That little squared means it's double. There are 2 of them, and instead of writing them as separate, we usually condense them together and make 1. So the little 2 means expand, write it twice, and then Chris, what do you get when you FOIL them?
I got d squared plus 18d plus 81.
Yeah. So that little 2 outside means your quantity is doubled. There are 2 of them. We're still foiling, but there are 2 quantities that are the same. You're foiling together. So the last one, the x minus 14 quantity squared, really means that's x minus 14 and x minus 14. So again, there are 2 of them. X minus 14, x minus 14. Maddie, what do you get if you have x minus 14 times x minus 14?
you get x squared minus 28x plus 196.
Yeah. Any questions on those first six? So the second group of problems, I want you to write the GCF of each pair. What is a GCF? Greatest common factor. Jack, how do you find a GCF? What are you looking for?
The number that's able to go into
Yeah, so find the number that goes into both values, and you want the biggest number. So Jack, the biggest number that goes into 15 and 30 would be 15. So GCF, the biggest number that divides into both of them. So 15 divided by 15, 30 divided by 15. 15 is the biggest number that will go into both of them. So a factor is a number I can pull out of them. Looking at the next one, we have 15x and 30x squared. So keeping the 15 and the 30, but applying an x and an x squared. So we know it's going to be 15. What else there, Chris? Yeah, why just x?
Because for 15, it's only 15x, but in 30 it's 30x squared.
Right, and the x, I can only take an x out of that first term. I can't pull an x squared out of it. Letter C, 15x squared y, 30x y squared. Alyssa, what do you think for letter C?
15x.
Right, 15xy. So when you're looking at those variables, you can only pull out the amount that's there. So again, the y here, I cannot pull out any more than that y. It doesn't have a y squared in common. They both don't have that quantity. The last one says a car travels with an average speed of m plus 7 miles per hour for m plus 2 hours. What distance does it travel? How would you do that problem? Why do you multiply them together?
Well, because it's the average speed for each hour, m plus 2 hours, so.
Yeah, so it says how or what distance does it travel? Distance is equal to your speed times time. So if I know how fast I'm going and how far I'm traveling, I can calculate the distance, or how long I'm traveling. I can calculate the distance. So multiplying these together, Nick, what do you get?
M squared plus 9m plus 14.
Right. And that would be equal to distance. So if I knew what m was, I could calculate my distance based off of the quantity that I'm using for speed and time. So that's just a little review. If you flip the page, we have a list, a big list, of vocab words that we're going to encounter throughout the chapter. Some of them we're going to see right now, and others we'll kind of work toward. But we have 3 different words that have that nomial part in them. So we have a monomial, a binomial, and a trinomial. Peter, do you know what a monomial is? Yeah, sure. So he said an equation, or we could say an expression with one term. So the MO part, 1. So Mina, a binomial would be?
Those are the ones we were doing.
Yeah, those are the ones we were doing. So they have 2 terms. So m plus 2, 2 terms. A plus sign separates a term. How about a trinomial? Jack? Yeah, that has 3 terms. And those were the answers, except for that one where the middle canceled. Most of the answers above had 3 terms. And most of the problems we'll be factoring are going to be similar to that. So we have 2 other terms, actually 3 other terms underneath. We have a quadratic function, which is the entire chapter that we are going to be working with. So this entire chapter is labeled quadratic functions and their graphs. A quadratic function is any function in the form ax squared plus bx plus c. So quadratic quadratic function we will be working with throughout the first 2 sections, factoring it, and then we'll start solving it in other forms. But this is a quadratic function, it has an x squared. The difference between a quadratic function and an equation is what it's equal to. So quadratic function has f of x. That's function notation we talked about in chapter 2. It passes the vertical line test. A quadratic equation is something that we solve for. So it's going to be equal to 0. So an equation we solve, a function we usually graph. But once it's equal to 0, it becomes something that we actually solve. So they're pretty much the same, it's just the notation. Again, the notation is important. What is the question asking for? Jack, you reminded us about the last term here. You said the greatest common factor is?
The number the greatest factor in two numbers.
Sure. And I'm going to say a variable as well, because it doesn't just have to be a number. A number or variable that 2 terms maybe have in common. We could even say the largest number that 2 terms have in common. So the first type of factoring we're going to review would be factoring using the greatest common factor. And if you look at the 3 examples, we're really going to do 4 different types of factoring today. So like a little review. Factoring with the greatest common factor method. You must always factor or try the GCF method first. So every question we look at, the first thing we'll think about is there a greatest common factor? If so, we want to take that out. We want to make the number smaller. So is there a greatest common factor that we can break down our numbers? And starting off pretty straightforward, we have 4x plus 8. So is there a greatest common factor with 4x plus 8? Yes. Brady, what is the GCF of 4x plus 8? 4. Do you remember how to factor the 4 out of the problem? So what does it mean if we're factoring it? What should our answer look like? Simplified. Josh? Yeah, so factoring means write something as a multiplication problem. It means pull the number out that they have in common and reduce anything, and that goes in parentheses. So they have a 4 in common. You're really pulling that out by dividing it away from the numbers that are there. And then whatever goes in parentheses should be the simplified form. So that should just be x plus 2. Factoring means change to multiplication. So anytime you see the word factor, your answer should be written as multiplication. So right now I have 4 times the quantity x plus 2. So we're multiplying those 2 together. Looking at b, 15a squared b cubed plus 20ab. So think of the numbers first, 15 and 20. What do they have in common? Then go to the letters. We have an a and a b. Jack, what do you think?
5ab times 3ab squared plus 4.
So he said 5ab, 15 and 20 have a 5 in common. They both have an a, but no more than an a. They both have a b, but no more than a b. Because the first one only has a, b. It can't have any more. And then you are really taking that and dividing each piece to get a simplified value or term inside, or multiple terms. So Jack, what did you say was inside again?
3ab squared plus 4.
So 3ab squared and then plus 4. So when you divide, remember you're really taking away powers. If we have 2, you're taking away 1. That's why you have an a left. If I had 3, I'm taking away 1, so we have 2. On the other side, 20 divided by 5 is 4. Those a and b's, there's only a power of 1, so you're taking that whole thing away. They pretty much cancel out. 3ab squared plus 4. So Michael, how about letter C? We have 10xy minus 30xy.
I took out a 10x.
Why can't we take out a y?
There's no y.
Yeah, excellent. There's not a y next to the 30. So Michael, if you take out a 10x, what do you get left?
Y minus
Perfect. Y minus 3. So factoring, change to multiplication. That's what factoring means. You're reducing whatever you started with. We're breaking it down. Questions? So that's method number 1. That's the method we will always look at first for any problem. The second method would be factoring trinomials that are in this form, x squared plus bx plus c. So now I have 3 terms. We have x squared plus 7x minus 8. So the first question, is there a GCF? Can they be divided by anything? Nick, do they have anything in common? No, because they don't all have an x. The 2 do in the beginning, but the last one doesn't. There's not a number that they have in common. Does anybody remember how to factor this? Peter, do you remember?
So you put two sets of parentheses down below,
2 sets of parentheses down below.
and then each parentheses has x in it.
Because when we FOIL, the first term is x squared, so those first terms have to be an x to multiply together to get x squared.
So then your other two terms have to add up to get 7 and multiply.
Right, so we're using the negative 8, that's called our C term. And he said they have to add up to be 7, multiply to be the negative 8. So Peter, 2 numbers that multiply to be negative 8. So he said a negative 1 and a positive 8. So 1 times 8 makes 8, and it's actually, and a negative 8 is what we're really looking for. But the factors of 8, 1 and 8. And then we need 2 numbers that combine to be 7. Well, negative 1 plus 8 does combine to be 7. So those will be the 2 factors that you're then placing in the parentheses. So we're using a negative 1 and a positive 8. You can always check yourself with FOILing. That's the great thing about factoring. Every problem should be correct if you do a quick little FOIL. So I have my x squared. Here's my 8 and negative 1. 8x minus 1x makes 7x. And then the last 2 term, negative 1 times 8. So this is factoring a trinomial. It's called the AC method. So multiplying a times c, using that c value to combine to be the middle numbers. So we're going to try this again. X squared minus 3x minus 10. So whatever that first term is, in most cases it's an x, but it doesn't have to be. I need to be able to FOIL those 2 terms together, so x times x. And then the last term is a negative 10. We need the 2 numbers that combine to be negative 3. So Chris, 2 numbers that multiply to be 10.
Negative 5 positive 2.
So negative 5 times 2 makes negative 10. But when you add them together, negative 5 plus 2 is negative 3. So those 2 numbers would be my factors. Minus 5 plus 2. Again, doing a quick little check. X times x. Here's a positive 2 minus 5. That gives me negative 3 and then my negative 10. The last one we have x squared plus 10x plus 6. So, Nina, what do you think? X squared plus 10x plus, or 16, not 6. What 2 numbers multiply to be 16?
8 and 2.
8 and 2, and how would they get 10?
You add 8.
Right, you add them. So an 8 and a 2. Questions? So we call that the AC method. So your GCF, do they have anything in common? And then the AC method is when you have a trinomial. And we're trying to still factor it, which means break it down into multiplication. The next group of problems, and I said we were going to do really 4 different ways to factor today. So there are 2 more that we're going to look at, and this is factoring using special patterns. So these problems have something special about them because the way they are written, or because of the numbers that are in them. So they really are like a pattern that we can follow. If you look at the 3 examples underneath, x squared minus 4, x squared minus 36, x squared minus 64. Notice there are 2 terms, so it's a binomial. But there's something special about the numbers. What's special about the numbers? They're all perfect squares. So this special pattern is called the difference of perfect squares. I cannot spell. There we go. So again, it's a pattern that we can follow. So the pattern says if you have one number that's squared or variable minus another number that's squared. So Alyssa said these are perfect squares. So we use an A and a B to represent 2 different numbers that are squared. The pattern then breaks it into 2 parentheses. One with a plus and the other one with a minus. So because they're perfect squares, what we're really doing is taking the square root of both pieces, and that's what goes in the parentheses. So taking the square root of A, well, I can multiply A times A to get A squared. Taking the square root of B, I can multiply B times B to get B squared. The reason I have 1 plus and 1 minus is that's how we get the problem to cancel. And I think JT was the one that did this for us. Right here. So my answer is going to look like this right here. Z plus 20, Z minus 20, because then those inside pieces cancel out for us. So if you look at the 3 examples underneath, we have x squared minus 4. So again, this is a pattern. It must be a difference. If it's not a difference, it doesn't work. It's the difference of perfect squares. And they have to be perfect squares. So we have to be able to take the square root of 4. So Ava, do you know how that's going to break down?
I got x plus 2, x minus
Yep. And that's it. So x times x makes x squared. Positive 2, negative 2 makes negative 4. Sadie, the second one, x squared minus 36.
X plus 6 in parentheses and x minus 6.
Right. And then Michael, x squared minus 64. Again, if it's a plus sign, it doesn't work. It must be a difference. It cannot work for a plus sign. The middle terms have to be able to cancel. Nina,
Wait, oh,
you sure?
yeah.
Okay. So we have one other type of all of this factoring. So it's still a perfect square. These were the difference of perfect squares. So I have 2 numbers that are perfect squares. The next set of examples are called perfect square trinomials. So perfect square trinomials. These are now 3 pieces. Again, that last number is a perfect square. And these have the pattern that the middle number is double the first and the last. So my first number is 1, my last number is 9. If I take the square root of each of them, the middle number is double the square root of those. The pattern breaks it down into A plus B with parentheses and then squared. This was like example 5 that we foiled from the beginning of class. So looking down at example 5, I have D plus 9 in parentheses and it's squared. So that middle number is being created because I'm multiplying that same number together twice. It's doubled. That's why we have a 2 there. There is one other pattern that goes along with it because it doesn't always have to be a plus. So the other pattern says a squared minus 2ab and then plus b squared. And then I would have a minus b squared. So I don't need to use the same method that we used for the other page if I recognize that that last number is a perfect square. So the key thing is to look to see, do you have a plus or a minus? So looking at the first pair of examples. If we have a plus, then we have a plus in the parentheses. If there's a minus, then we have a minus in the parentheses. So again, this is because they're perfect squares and it's a perfect square that's a trinomial. So Dimitri, how would x squared plus 6x plus 9 factor?
For
So this guy right here.
the x plus 3 and x plus 3, so b squared.
Yeah, so it would be x plus 3 squared. So again, using this pattern, you're really taking the square root of the first number and the square root of the last number. The middle number kind of gets forgotten about because that's there for when you FOIL it back. So if I FOILed this, I'd get the 6 by taking x plus 3 times x plus 3. I'm doing that twice. That's how I get the 6. So it's not really there when you use it to factor, but if I FOILed it, it would be in the answer. The only difference from the one below is that it's a minus sign. So again, it's a quantity squared because we're dealing with perfect squares. 3 times 3 is 9, or 3 squared is 9. And then the next one next to it here, x squared plus 10x plus 25 versus x squared minus 10x plus 25. Veronica, do you know how that would factor?
The first one, the top one?
Yep.
X plus 5 and then 2 x.
Right, and then the one on the bottom would be
X minus 5 squared.
x minus 5 and then that quantity square. So if you can recognize that they're perfect squares, you're taking the square root and then just factoring it as one set that's squared. Questions? So those were 4 ways that you learned to factor in Algebra 1 that you should have done a pretty extensive review last year in geometry as well. Keeping my fingers crossed that you did. Seems like everybody still remembers. So see if you can factor. There's 5 problems. The first 2 say to factor with perfect squares or special patterns. And then the bottom 3 is just a review of factoring. It could be any of the methods. Brady, how would you factor x squared minus 25?
X plus 5 and x minus 5.
Thanks. So 2 terms, binomial. Perfect squares, in order to get that middle term to go away, we need that plus and minus, so that when you FOIL them, they cancel out. A negative 5 and a positive 5 go away. The second one says m squared minus 22m plus 121. Jack, what do you have there?
N minus 11 squared
And why do you have a minus in the middle there?
because the negative 22n.
Yeah, so that negative 22m gives us the minus in the middle. So underneath, we have x squared plus 7x plus 12. So 12 is not a perfect square. That means we cannot factor it with the pattern of a perfect square. How do we factor x squared plus 7x plus 12, Chris?
You have to do the one word, so yeah.
Yeah, so we need to think what numbers multiply to be 12.
4
4 and 3. And if we're adding to be 7, they would have to both be
x plus 4 and x plus 2.
Right, x plus 4, x plus 3. Letter B, we have x squared minus 81. How would you factor letter B?
X plus 9 and
Right, x plus 9, x minus 9. So this is two terms. This is our special pattern. 81 is a perfect square. So when we factor it, we have the plus and the minus of the same number. And then the third one, x squared minus 7x plus 6. How would that one factor? Leah, how would we factor that one? What makes 6? 3 and 2, 1 and 6. How would we get a negative 7? And negative 1. So if I multiply them together, a negative and a negative make a positive number. But when we add them, negative 1 and negative 6 makes negative 7. Questions? So your homework for today, due Thursday, is on page 255 and 256. And it goes through the 4 different methods of factoring. You're doing all of those problems, 3 to 23, all of them. Again, it's due Thursday. Anybody interested in doing 14 or 22? Gabby, 14. Josh, did you do 2 already or no? No, you got 1. So Josh, number 20.